Okay, so let us finish off our last and final video, which is on LempelZiv. Okay, so LempelZiv, right? Your tutorial is only LempelZiv77. You're not going to see much of LempelZiv SS. There's nothing about LempelZiv SS. Okay, if you look at your lecture slides, right, majority is on LempelZiv77. Your LempelZiv SS is only like what 2 slides, 3 slides. Okay, so I'm going to try to explain as much as possible. My focus will still be on LempelZiv77 because LempelZiv SS is just a simplification of LempelZiv LempelZiv SS is just an optimization of LempelZiv77. Okay, so what you need to know about your LempelZiv. Okay, I'm going to use your tutorial question 4, right? I'm going to perform for both LempelZiv 77 and LempelZiv SS. Okay, so go to the whiteboard. Let's say my string is going to be BAR BARR underscore BAR underscore BY underscore BAR RAYAR underscore BAY. Okay, so this is my string which I want to compress, right? So your LempelZiv 77 or LempelZiv SS is actually a compression algorithm. Okay, so let us just limit it to LempelZiv 77 for now. Okay, the concept of LempelZiv 77 is very simple. If I were to if I were to encode each and every character one by one, it's going to be a bit, or 1 byte, 1 byte, 1 byte, 1 byte. And you realize I'm going to be wasting a lot of memory, right? I'm wasting a lot of bits. So what if I'm able to use numbers to reduce my dependency of the characters itself, right? For example, if I know it's ABC, right, instead of saving all 6 of my characters, right, instead of saving 6 times 8 bits, right, which is 48 bits, okay, I can actually only save ABC, right? So here will be 24 bits, okay, and then here I just say repeat the previous 3 characters one time, right? So previous 3 characters, I want to repeat 3 of the characters, right? So because I'm saving numbers, I can use alias, right? And if I use alias, I can save a lot of bits, right? And hopefully the entire purpose is I want to have very long sequence. For example, A B C D E F G H I, A B C D E F G H I, 1 2 3 4 5 6 7 8 9, right? 9 times 9 bytes, right? And then here I just save like 9, right? So my numbers will help me save a lot of bits. Okay, so inspired by such a form, okay, your LempelZiv have the following arrangement. Okay, so it's going to be offset, comma, length, comma, next character, right? So offset, length, and next character. Note I'm showing you comma here, but as we have seen from my alias encoding video, where I combine alias and Huffman to actually explain to show LempelZiv, right? My comma doesn't actually exist, right? So what you're going to see is alias of offset, okay, alias of length, and finally Huffman of next character. Right, so this is how it's going to be. Another important note is you're going to be given a dictionary I won't call it a dictionary. It can be a bit confusing, right? We have something called the window size and also the buffer size, right? Or let's call it the load array. Okay, so in the example I gave you earlier, where we look at the back, right? So A, B, C, D, E, A, B, C, D, E, right? So here is our window, here is our load array, right? You want to look for the matching substring between your window and also your load array, right? And imagine if I could not have a window size, right? And my string is very long. Are you going to compare the characters one by one? No, right? It is very inefficient because you are actually performing way too much time complexity, right? In order for you to find the similar alphabets, and it is not worth the effort. So we made a window size which actually say enough is enough. Please do not overdo it, right? Please do not overdo it. Okay, so let us try the following LempelZiv at the moment. Okay, so if you were to look, let me just put numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so I actually have 28 characters. And in your assignment, in your tutorial question, you're given the following: window equals to 15, okay, load ahead equals to 15. Okay, so let us begin. When I begin, right, what I'm showing you here is the separator, right? So what you see here is the separator itself. So when I separate here, right, what it means is my window goes up to 15 characters on the left, and my load array goes up to 15 characters on the right. Okay, so what you want is you want to look for the suffix, right? You want to look for the suffix in your window, which will give you the longest length, right, or the prefix in your load array, right? So I repeat, I want to look for the longest prefix in my load array which matches my suffix. Okay, the longest prefix in my load array which matches the suffix of my window. Okay, so at the start, you're going to realize my window is empty, right? Because my window is totally empty, right? I do not have anything to use, right? I have nothing to use at all. So my first one is going to be, right? My first one is going to be none. Let's just put a none, right? 0, and the next character is B, right? So what it is telling me is I could not have any reusable, so that's why here is a none, right? Or if you look at the sample answer, it's actually an underscore, or if you look at your slides, right, underscore is a dash, or whatever, is up to you, right? There's no matching characters between my prefix and my suffix, right? It makes sense because my window is empty, and the first character after my match, I have no match, the alphabet is B, right? So because now I'm currently at B, right, my first slice will now be L, right? This is now where my size is. here I can go up to 15, here I can go up to 15, which should cut at 6. Okay, so what is the longest prefix which matches my suffix? Okay, so here is A. I will try to search for A. I do not have any A on the left, right? So my answer will be 0, right? Nothing reusable on the left, length of 0, and the next character will be A. Okay, so my next slice is going to be here. So once again, 15 characters, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? And here I'm going to have 2 characters on the left. Okay, my prefix begin with R, my suffixes, none of it begin with R, right? So it will still be 0, 0, R. Okay, so I now slice here. So 15 characters, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? I should stop at 18, right? Yeah. What is the longest prefix which matches my suffix? Okay, so if you see here, my prefix begins with R, so I need to look for R, right? But the only match is only one R, right? So what it's telling me is my suffix begin one character from the right of my window, okay? And I want it to repeat one time, right? Because R and R, I want it to be repeated. So instead of me using 8 bits for R, I can just use 1 bit for my alias of 1. Not actually 1 bit. It's actually 3 bit for my alias of 1, because I begin from 0, 3 bit for alias of 1, right? And finally, A, right? My next character is A. So it will be 1, 1, A. Right, my answer will be 1, 1, A. 1, 1, A. Okay, so here is where my slicing is, right? So 6 plus 15 is 21, minus 1 equals up to 20. Okay, what is the longest prefix of my lower 8 which matches my suffix? Okay, do I have any longest prefix which matches my suffix? So if you see here, my prefix begin with Y. I do not have any Y over there, right? So it will be 0, 0, Y. Okay. Now, isn't it very, very inefficient for me to calculate all of the numbers? Ask yourself, isn't it very efficient? Right, because I need to Y compare 1 by 1, YA compare 1 by 1, right? So you're actually doing a brute force packet matching to look for the longest prefix in my lower 8 which matches my suffix, right? So if you do the brute force comparison, right, you're going to minus marks, right? Because it is very, very efficient. But you have learned something in your first lecture, right? So now we are in week 10. We go all the way back to our week number 1, Z algo. Okay, so what you want to do is you want to use a Z algorithm, right, which will help you find the longest prefix in your lower 8 which matches the suffix in your window, right? So I can't say anything more, right, because you need to implement it in your assignment for sure, right? Think about how you can use both portions inside your Z algorithm, right? So you can compute it in O of n plus m, where n is the length of suffix and m is the length of n is your window and m is your lower 8, right? So it depends on your Z. Okay, it depends on your Z, right? And it is not as simple as you think it is. And also, I do not want you to slice concatenate, right? Because remember, when you slice, it requires additional complexity, right? So slicing is actually very slow. Based on the previous marking scheme, if you slice for very large input, it will not even produce any output. You will lose marks at the output, and you will also lose marks. You are going to lose marks in your output, and you are also going to lose marks in your implementation, right? So what happens is, in your Z algo, right, your argument is going to be string, which is the entire string. Then it's going to accept your argument of I and J, right? Or in other words, I is where your window begin from, J is where your buffer your load array buffer begin from, right? Then you're going to use Z to look for the longest prefix in the load array buffer, which matches your suffix, right? And afterwards, as I go through more examples, you're going to see a little bit more. Okay, so I'm done here. Next one will be the following. Oops, right, it will be 00y 00y. Then here is where my slice, it will be up to 21. Okay, AR, do I have any AR which is usable? Do I have any AR which is usable? Do I have any AR which is reusable? Think a bit more. Okay, so all of the gains here are suffixes. I want to look for the prefix, right? AR underscore, right? So let's look for A, right? A actually occurs here and here, right? Then R actually occurs here. So in other words, here are the mapping which I want. Okay, so the longest prefix which matches my suffix. Okay, so it doesn't mean it goes all the way to the end, right? So if I were to refine my definition, here is actually a substring, right? It is not actually a suffix. It's more of a substring. There's no requirement for it to go all the way to the end, right? That's why your Z algo will actually make more sense, right? So this is the first one. It doesn't mean it need to go all the way until the end. Okay, afterwards I will show you a little bit more where you realize it can even cross the border, right? Which I will explain afterwards as well. Okay, so here if you use the Z, right, so it'll be what? AR blah blah blah, dollar sign BARRAY, right? So here you're going to have Q, here will be 0 0 0 1 0, right? So you can see Q is the biggest number among here, right? But it's much more complex than you think it is as I go through more and more examples. Okay, so I know these are the good portion which match, right? So it will be 1, 2, 3, 4, 5, right? So 5 position to the left, right? So 5 position to the left, and it matches to alphabet, which is here, right? And the next alphabet is my underscore. Okay, so it will be 5 Q underscore. Okay, 5 Q underscore. Then I'm now over here. 15, 10 plus 15 should go up to 24. Okay, so B, right? Do I have any B? Only B is here. A, R, anything else? Underscore, and it's not the same. So you realize it's very similar as your Z, right? Except your prefix is going to be here, right? This is where your prefix is going to be. It's very similar with your Z, right? But with a little bit more complication as I show you afterwards. right? So if I give it 5, right, your window is more to a substring and not really a suffix, right? So that is where some of your first confusion is, because from your lecture sites, it doesn't make it obvious that it's a substring, right? Your lecture sites example, if you look at your lecture sites example, right, you realize A and A are actually suffixes. AAC are actually suffixes, right? CAB is actually suffixes. A and A is actually suffixes, right? So the example was showing suffixes, but if you were to read the definition which Arun provided here, right, you realize it's written substring, right? The largest machine substring, right? So this is where most of the confusion is. You want a substring, right? And which is why your Z algorithm will actually work. Okay, so it's just something which I would want to clarify. Okay, so BAR, how many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so 9 to the left, rank of 3, and the next alphabet is here and underscore, right? So 9 3 underscore. Okay, since my space I will put here 9 3 underscore. Okay, so I now slice here. I still got 15. 14 plus 15 is 29 minus 1 28. 28. Yeah. Okay, so I'm going to use my Z again, B, right? I have two B's. Do I have any BY? You realize I do not have any BYs, right? So you're going to come across a scenario here, right, where the match is only 1. So if the match is only 1, means I have two options, right? I can choose 1, 2, 3, 4, or I can choose 5, 6, 7, 8, 9, 10, 11, 12, 13. Right, so should it be 4, 1, Y, or should it be 13, 1, Y? Which one should it be? Which one? Right, obviously we are going to choose the smaller one. Why are we choosing the smaller one? If I want to encode 4, you compare the number of bits required for alias 4 versus alias 13. Right, so in your Z algorithm, right, you will, if you have two numbers which is 1, you will prioritize the closest one from the back, right, the closest one from the back, because it will give you the smallest offset. Okay, so it will be 41Y, right, 41Y. So 41Y, right, so the next one will be 41Y, right, so 41Y means I'm currently over here, right, 41Y, is it 41Y? 41Y, yeah, okay, so this is a balance here. Okay, then I'm going to repeat the same again, right, underscore BAR, right, you're going to realize underscore BAR, right, here is the only length which actually makes sense. So it will be 1, 2, 3, 4, 5, 6, 7. How many alphabet? 4 alphabet, right, and the next alphabet will be R, so it will be 74R, right, 74R. 74R. Okay, so 74R. I'm going to end over here, right? It will be 1, 2, 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is where I'm going to stop. Okay, so my window is going to be here. My load array is going to be here, right? So I'm going to load A, and my next alphabet is Y, right? Which I don't see a Y anywhere. So I will always choose the closest one. Which one is the closest one? The one here. So 1 to 3, so it could be 3 1 y, right? It should be 3 1 y. So if it should be 3 1 y, let me just do the following. 3 1 y means, if I'm not mistaken, I'm stopping here. 1 2 3 4 5 1 22 minus 15 is 7. 7 plus 1, 7 plus 1 will be 8. So I should stop at position number 8, right? If I'm not mistaken. Okay, so once again the same step. A R underscore underscore, right? Then B A cancel F, right? So my longest length is only 4. This is my longest length, which is 4. Okay, note, if you look for AR underscore BAY, you're going to see a AR underscore BA, right? Over here it will give you a length of 5, right? Here it will give me a length of 5, and you realize 5 is greater than 4. But why am I not able to use 5? Because the A is outside of my window, right? So I'm not able to use it, right? So because my A is outside my window, I will not be able to use it, right? So this is the only one I'm going to be happy with. So it'll be 1 2 3 4 5 6 7 8 9 10 11 12 13, right? So it's going to be 13 4 A. Is it 13? 1 2 3 4 5 6 7 8 9 10 11 12. Oh, it should end at here, right? So it should be 12 4A. 12 4A. It should be 12 4A if I'm not mistaken, right? 12 4A. So 12 4A, I think I end at here, right? Wait, where was I already? I think I end here, right? AR underscore B, AR underscore B, AR underscore B, yeah. Okay, so it will only be 1. 27 minus 15 is 27 minus 15 is 12 plus 1 will be 13. So I will stop here. Okay, so it's only Y. It is only Y. Y is my closest Y. This is the closest Y. 1 2 3 4 5 6, right? So what you're going to see here is going to be 6 1 and 6 1 and terminal, right? So I've terminated my string, right? So it's going to be 6 1 terminal. So I know I have already finished my string. Okay, so what you see here is my LZ77. Okay, now I'm going to show you another case, right? Assume it is A B A B A B C. Okay, let's say my window is 3, my log 8 is 7, let's say. Okay, now let us try to do it one by one. Okay, so the first window is going to be here. Let me put numbers again. 1 2 3 4 5 6 7, right? Let's not put 7. Let's change the window to 5. Yeah, 5 sounds fine. Okay, so this will be my first one, nothing all the way up to 5, right? So it's going to be none 0 A, right? Which is only the first alphabet. Okay, so my first one will be none 0 A. Then I will slice it over here, 5, right? my prefix is B. Could I see a B? I could not have a B. Means it's going to be a 0, 0, right? And B, right? So it will be 0, 0, B. 0, 0, B. Then I will slice here, 5 characters, and over here. Okay. Now you're going to notice something interesting, right? A and A is a match. B and B is a match. Okay? So if I were to draw it out, match and match. But you realize A and A is still a match. So the ones here are also a match. Let me use green. Right? And then the B and the B here is also a match. So what is my proper answer? My proper answer is actually the following. Right? I move 2 places to the left. Right? Means I begin from here. Right? 2 places from the left. And I want to match 4 alphabets. Right? So it's going to be Q4C. Right? And the last one will be 0, 0 terminal. Because we want to end with terminal. Okay? Why is it Q4C? Okay? So the trick is both alphabet here and both alphabet here is a match. Right? But I could not only look at it ending here. Right? It actually goes beyond. It can actually go beyond. Right? So in other words, the number here, right, can be greater than the number here. Right? If you look at everything here so far, you're going to notice a pattern. Right? The second number is always smaller than the first, smaller or equals to the first number. Right? And the example here doesn't actually show it. Then if you look at your lecture slides, right? If you look at your lecture slides, right? If you look at your lecture slides, okay, you're going to see this part here, which is what this thing is. Alright, okay? So what you're going to see is A and A is the same, A and A is the same, C and C is the same, then A and A is the same. Right? But because this alphabet and this alphabet is the same, right? Remember what happened? Here and here is the same, right? So I know the first alphabet in my window is the same as the first alphabet in my lower 8. Same, 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 right? So when I reach here, right, when I were to compare my alphabet, when I compare my good alphabet here, right, you realize it's the same as comparing with the first alphabet because the first alphabet here and the alphabet here is the same. So if this alphabet and this alphabet is the same, it's the same as the other alphabet, right? You understand? You understand what I mean, right? So it's going to be the same concept as your, as how you see here, right? So I know this alphabet and this alphabet is the same, right? So when I'm comparing the alphabet and the alphabet here, it means it's also the same as me comparing here. So instead of me doing a cycle of A, B, A, B, A, B, right, I can just extend it all the way. It's up to you to implement it, right? If you were to slice it and you follow a circular copy and paste, it's inefficient because you slice and you copy, right? But if you just follow the alphabet all the way, right, it's going to be very, very, very nice. Okay, so if I were to do it in reverse, which is what you're going to see here, right? So 9-0-A, I know my first alphabet is A, then 0-0-B, nothing to be used here will be B, then Q4C, right? So copy the Q right? Repeat it 4 times, right? 4 characters, so it's going to be A, B, A, B, right? So what I think could be happen is copy A, 1 character, copy B, 2 character. Instead of copying the first one again, I will just copy the next one, which is A, 3 character, copy the next one, which is B, which is 4 characters, right? So it's going to be A, B, A, B, and the next character will be C. And last one, 0, 0, terminal. This is what I'm going to have. Nice, simple, clean. Okay, nice, simple, and clean. Okay, so that is how I actually reverse the process, right? So let us try to reverse another one, right, which is over here. Okay, so let me just copy it, go to the whiteboard and paste it. Okay, it doesn't work. Okay, it's fine. I just manually copy it. 0, 0, R, 0, 0, A, 0, 0, key, Q8 key, Q8 underscore, Q8 underscore, 3, 1 underscore, 0, 0, R, right, 0, 0, R, 6, 4 key, and 9, 5 key. Okay, so let us try to now rebuild our original string. Okay, 0, 0, R, right, means I cannot reuse anything. 0, 0, R means only R. 0, 0, A, 0, 0, key, red. Okay, Q8, right? So this is Q, right? So I'm going to move 1 Q, then I'm going to repeat for 8 characters. 1 character, 2 character, 3 character, 4 character, 5 character, 6 character, 7 character, 8 character, right? So it will be A key repeated 4 times. So, right? So think of ways to implement it efficiently in your assignment. 2, 3, 4, right? So finish, 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 right? End with an underscore. Then the next one will be 3, 1 underscore, 1, 2, 3 will be A, followed by a underscore, finish, 0, 0, R, right, 0, 0, R. You notice, right, when I decode, I don't care about my window, I don't care about my load A. I don't care at all. It's not required, right? Because your window and your load A is only required when you want to encode. When you want to decode, it's totally not important here, right? You realize I do not require it. So it's another thing which I want you to take note of. Okay, so 0, 0, R is finished. 6, 4 key. 1, 2, 3, 4, 5, 6. Right, I want to repeat how many times? 4 characters, right? So it's going to be 1 character, 2 character, 3 character, and 4 character, right? So I want a length of 4, right? So let's use 1, 2, 3, 4, 5, 6. I want 4 characters, right? So it'll be A key underscore A, right? A key underscore A. So it'll be A key underscore A. Okay, and the last one will be 9, 5 key, right? 9, 1 2 3 4 5 6 7 8 9 5 characters 1 2 3 4 5 right. Is it 95 key right? Wait, no, I missed out the key earlier right, because there's a key at the back, so my bad, I messed up right. So it'll be 9 1 2 3 4 5 6 7 8 9 right. Then I want to repeat 5 characters 1 2 3 4 5. Okay, so it's going to be underscore a underscore ra underscore a underscore a underscore ra. Okay, so is keys actually correct? Okay, if I were to compare with the answer, the rakaka is correct, is correct, red is correct, a is correct, key is correct, underscore is correct, ar, and followed by a key, right? Don't miss out your last key, right? So usually a common mistake is we always focus on the numbers and we forgotten about the alphabet at the back, right? So that is where the careless mistakes are. But it will be your original string, right? So you realize the window and the load 8, right? I never use them at all. It is not important at all. Okay, so that is what your LempelZiv 77 is. Okay, so the problem with LempelZiv 77 is, right, you realize of this 0 0, right, it's actually a waste of memory, right? Because I need to do alias of 0, alias of 0 followed by argument of a, alias of 0, alias of 0, argument of r, alias of 0, right, as we saw earlier, we can represent it as 0, alias of 0, alias of 0, argument of b, alias of 0, alias of 0, argument of y, right? You realize you are actually wasting a lot of space. Okay, so this is what your LempelZiv, your LempelZiv SS is, right? This is what your LempelZiv SS is. Okay, you are going to be set a rule, right? If the length is 3 and above, we are going to use 0 offset length, right? If the length is less than 3, it's going to be just the character, the current character. So you notice, right, we do not care about the next character at all, right? The next character is not important. So let us try it with the example here, right? So let me set a few rules, right? 0 if length, right, is less or equals to 3, right? Is it less of, no, wait, is more or equals to 3, right? 1 if length is less than 3. Oops, wrong one. Okay, so I've already established the rule here. Now let us try one by one. So here I have nothing to use. The current character is only b, right? So the length is less than 3, it will be a 1, right? So it will be a 1 bit, right? Note this is a bit, right? It's not alias, this is literally a bit, 1 bit. Then I will slice here, right? Because we know it's 3, right? In other words, I know all my first 3 characters is going to be 1, right? So it will be 1a and 1r. Okay, so this is the bug you're going to see, right? So here is my kitchen, here is my window, here is my load 8 to 15, it should go all the way up to 19, 18, right here. Then compare the character r and r, right? I only have 1 character with match, which means my length is less than 3. So if my length is less than 3, it's still going to be 1r. So I'm now here, right? Then the same thing, right? You realize A, I cannot follow up anymore. You realize my length is here 1, so here is going to be 1A. Now I'm ill. Y, there's no Y, right? 1Y. Okay, so here comes the fun part now, right? 7 plus 15 is 22, minus 1 is up to 21, right? So A, R, and R, that's all. You realize I can only match two alphabets. So if I can only match two alphabets, it's here under here, right? So I know despite it being AR, I'm just going to do 1A, right? 1A. Then I'm going to slice here. R underscore, right? I have an R, but I do not have an underscore, so it's going to be 1R underscore. I'm going to not have 1 underscore. I'm going to slice here. Then it's going to be 24 over L, right? Then I'm going to see a BAR, right? BAR and BAR. Okay, because it's BAR and BAR, right? I'm going to use a because the length is greater or equals to 3, I'm going to use 0, right? Remember 0 bit is a bit, it's not the alias of 0. It's not alias of 0, right? Then how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And what is the length? The length is going to be 3. Okay, so 093. 093, right? So 093, I will be L. Okay, then the next one is only underscore by. So the only similarity is underscore b, which is not really usable, right? So it's going to be 1b. I slice here. Y underscore doesn't have a y underscore anywhere. I only have a y, 1y, right? Slice here. No, it will be 1y. Then I will slice here. Okay, now we are going to see underscore bar, which I can see here, right? So it's going to be a length of 4, which meets my requirement. So it will be a bit of 0, right? 0 bit. 1, 2, 3, 4, 5, 6, 7. How many characters? 4. So it will be 074, right? 074. Right. Then I will be here. Then 15, so it will be 19 minus 15, 15 plus 4, it will be here. Okay, so I'm going to once again look for my match. RA, I could not have RA anywhere where I only have a R, right? So you're going to notice something, right? You realize my offset numbers, right, are generally small compared to the numbers here, right? Because my offset numbers are small, right? You might go and go the offset numbers. I'm saving a lot of bit, right? Because I'm keeping my area small. Imagine here, right? If you see, the only match is R, right? The nearest R is L, which is fine, right? But imagine if this is not R, right? Imagine if this is X. Where is the nearest R? The nearest R is actually L. So if I want to encode the offset, it needs to be 1, 2, 3, 4, 5, 6, 7, 8, right? So it needs to be 7, 1, and something else. You realize the 7 itself, right? The alias of 7 requires how many bits, right? 7 can, to binary, it will be 1, which is 4 plus 2 plus 1, right? To can will be 1, 0, 2. Then it will be 1, 1, right? So to encode 7 alias of 7, right? Alias of 7 is actually 0, 0, 0, 1, 1, 1, right? You realize how many bits I need to encode, right? You realize how many bits I need to encode. Whereas if I use this way, it will just be 1R, right? So 1 bit versus 1, 2, 3, 4, 5, 6. And hopefully the argument of my R is small enough, right? But here I need to have the next character anyways, right? So it pretty much cancel off very nicely. Okay, so this is one of the reasons why for in the real world example, your LempelZiv SS is actually better on average. Right, your LempelZiv SS is actually better on average. Okay, so here I'm just going to be 1R, right, 1R, and the swing which I'm showing you here, right, is actually a very bad swing, right? It is actually quite a bad swing. Shit, I can't remember where I was already. Where did I stop at? Reverse 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right, so I was at the R at position number 19, so I'm now at 20. Right, so another nice thing is I can trace it back very easily. Right, so I believe just now I was here, which is 1R. Right, so here will be my next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. Then I have a A, I have a A, I have a A, I have a A, do I have a AY? I could not have a AY, right? So here you can actually see another advantage. Here will be just 1A, right? I only require 1 bit compared to me needing to save the alias of 1, 2, 3, right? Instead of me going 3, 1, right? Here versus here. Right, you can see the alias of 3, alias of 1 is going to be more than the 1 bit followed by the argument of A. Right, so you are actually saving a lot of memory. Okay, so it will be 1A. Shit, where I was again, 19, 21, here. Okay, so 21 minus 15 is 6, 6 plus 1 is 7, right? Let's just look for YA. Just off. You understand the concept, right? The swing which I'm showing you here is actually very bad for the LempelZiv SS, right? But you can still see, right, why LempelZiv SS is actually more efficient, right? And why we actually established such a rule, right? In other words, if the length is short, the offset is going to be very far. If the offset is very far, the encoding of the offset is overwhelming everything, right? So if you were to see here, if you see here, what is the alias of 12? What is the alias of 4? Right? Alias of 12 and alias of 4, right, is actually very long. In fact, I can save like so many more alphabets, right? So this is the reason why we set such a rule, right? Only after a certain length we will say the offset is worth it, right? Or else the offset is not worth it. Okay, so this is one of the important concepts here, right? Why our LempelZiv SS is actually more useful compared to LempelZiv 77. Another reason why, right? Another reason why our LempelZiv SS is better is, you know, for alias encoding begin from 1. It doesn't begin from 0. But if you look at LempelZiv 77, we need to account for alias of 0. Means if you look at my alias video, we need to shift our alias to the left for it to begin with 0. When we shift to the left, automatically we make our alias encoding actually longer. But you see here, right, you will never find 0 anywhere, right? You will never find 0 because you cannot have a 0 offset and you cannot have a 0 length. In fact, the length is only possible if it's 3 and above, right? So if you were to write the alias of 1, 2, 3, you're going to understand why we choose alias of 3 and above. The 0 which you see here are actually bits, right? They are actually bit. They are not alias of 0. They are actually bit. They are actually big and they are actually not alias of 0. Okay, so with that, right, I've actually explained more than your tutorials, because if you look at your tutorials, right, your tutorial doesn't have any LempelZiv SS. I include LempelZiv SS. I've also explained, right, when you want to perform the match, you need to use the Z algo, right, but your Z algo have to be modified. So from marking your assignment 1, I know some of your Z algo is very well done, where you pass in index and you cannot slice the string. But the rest of you, I've actually noticed a lot of string slicing, which is very, very bad, right? So over here, you need to modify your Z algo not to slice your string. Let's say if you do not have time or you're very stressful, FIP and so on, if you do not want to modify your Z algo, just leave it, size your string, but note there's a very high chance you will be penalized based on the marking rubric, right? So you're going to use the Z algo to compare the substring in your window versus your prefix, my bad, right? So it will be prefix, it will be substring. Okay, so this is the part which I want to highlight, because in your lecture slides, right, you realize all of the examples are actually suffixes, right? So it is actually very, very misleading, right? And it's the cause of some of the bad implementation or confusion from your seniors. And if I were to be honest, I keep explaining it in my tutorials, they choose not to listen, they deserve to lose marks, right? So now with the recording, I've already explained everything. I do not want you to lose marks over here. Okay, so with that, I've finished your tutorial number 10 and hope it will be very useful for you. Okay, bye.